So thank you for coming to this presentation entitled Continuous Deployment of Your Application. I know there are many other talks that are much more interesting, so thank you for coming to this one. Before we go to the main topic, I'm going to say just a few words about myself. So I work as a Spring Cloud developer in a company called Pivotal. Who has heard about Pivotal? Pivotal? That's nice. For those who don't know, we're doing Spring and Spring Cloud and Spring Boot. And I'm leading those three projects, Loop, Contract, and Pipelines. My Twitter handle is @Grzejszczak. If it's too difficult for you to type, just go to my blog, toomuchcoding.com, and find it there. Okay, so to start with a question. Who had to create a deployment pipeline from scratch? Okay, the rest already had it, or they just have a manual pipeline, I guess, like this is my USB stick with my app, go ahead and run it, right? Okay, so quite a few people, that was expected. Now, whose deployment pipeline looks more or less like this? Don't be shy, we're friends here. We're friends, okay. So if you're wondering, the end-to-end tests are here, and yes, they take 15 hours to run. So that's a typical deployment pipeline, or looking like in a pretty common way. So what problem are we trying to solve? What kind of a problem trying to solve in this presentation? Because, you know, you can do the hype-driven development or conference-driven development. So you go to a conference, you listen to somebody say something, you just apply it. But maybe it's better to first ask a question if we have a problem, because then we can apply a solution. Because if we don't have a problem, there's no point in changing anything. So the problem we're trying to solve is the necessity to create a deployment pipeline from scratch for each new project. Typically, because we waste time, and also because the pipeline we're creating is not necessarily the best. So this is the pipeline we'll be talking about today. I mean, you can't see much. Don't worry, we're going to cut it into pieces. So this is the pipeline that is built in a tool called Concourse. Who heard about this tool, Concourse? Okay, a couple of people, good. Who has seen this? So a pipeline using Jenkins, okay. But you might have seen this ugly, endless pipeline in one row that if you run for too long in a browser, makes your browser crash. So I prefer to have this is called the delivery pipeline view. Who has seen this? Okay, quite a few people. So this is Blue Ocean, so the new UI in Jenkins, and you have to use the Jenkins file to define the deployment pipeline. So we're going to be focusing on the Concourse one, but that doesn't really matter because, as you can see, or not really, but trust me, those steps are exactly the same in every single automation server I've shown you. So what are we going to work with? We're going to have a certain flow. We're going to have GitHub that emits hooks, let's say messages. And there's an app called GitHub Webhook that listens to those HTTP calls. And when the message is processed, another message, when the HTTP request is processed, a message is sent to via MQP to GitHub Analytics, another app, and we'll be focusing on that app a lot today. So now, before we go to slicing the deployment pipeline, the one that we think is a kind of a reference to a way of deploying software to production, we should first ask ourselves a question: why do we even deploy software? Because maybe some of you have forgotten, but actually we're paid for delivering business value, right? So we have to write a feature, and only after the feature is done and deployed to production do we get the money. If we deploy to test, it doesn't matter. If we deploy to stage, neither. Only if a feature is on production, doesn't really matter, and we earn money. And we would like to deploy frequently for faster feedback. So, of course, I know that there's not a single person here who does deployments like, let's say, every 6 months or so. It's for sure like every week or something, at most every week. So I'm just saying that it's very good to actually deploy frequently. Why? For various reasons. From the technical perspective, we want to see if our small pieces of code that we've committed between deployments actually work fine. Because, you know, statistically, we're going to have fewer bugs when we deploy every day rather than we deploy every 6 months, right? So from the technical perspective, it makes a lot of sense. And from the business perspective, it makes plenty of sense because the business can see whether the business ideas make sense or not. It's better to waste, for example, a month of 4 sprints to see that like a couple of features bring us no money, rather than wasting a year in a project to see that nothing works. It's better to fail as fast as possible. And this is the very essence of today's deployment pipeline. We always want to fail as fast as possible, especially without even pushing the code. So the developer can run some stuff on their machines and see that some stuff got broken. So this is our main idea. We want to standardize the way we do deployments. I worked once in a company where running of apps was done via a script called run.sh, start.sh, manually via no-hub, and other hideous stuff. So you never knew actually how this particular process was started. So actually it's better to make all of that automated and standardized. Who has a step in their pipeline that tests rollback? No, I can't see a single hand. That was expected. So we would like to test it. I'll show you how we can do it in an easy way. Because if we can test rollback, that means that we can have 2 apps running at the same time. The current one and the old one. Which means that we can do zero downtime deployment. Which means that we can do all sorts of stuff, and we will be less scared of doing deployments. So let's focus on these things, like faster feedback. So we are at the first 2 stages: build and upload, build API compatibility check. So these are 2 first steps of the pipeline. The first problem we're trying to solve is slow feedback. Of course, you have the proper testing pyramid, a lot of unit tests, some integration, a handful of end-to-end UI, and just a couple of manual tests for critical features. Who has such a pipeline, such a pyramid of tests? Who has the reverse one? Oh yeah, I know that everybody's shy, don't worry. We've all been there. So we don't want to do it. We want to inverse it, because running end-to-end tests is very problematic, slow, and it's really frustrating to see that you made a typo when you were calling the API after the 14th hour of running end-to-end tests, right? So you have no unit tests, no integration tests, or like a minimum number, 14 hours of running tests on some end-to-end test environment, and you made a typo in the API. Nothing is as frustrating as that. So we would like to fail fast, even during the build time, especially if integration is faulty, or if our API is backward incompatible, the change is incompatible, right? Because if we want to do eventually zero downtime deployment, we need to ensure that the database changes are backward compatible and API is backward compatible. So we're going to see a couple of Captain Obvious solutions. So if the problem was slow feedback, the Captain Obvious solution is going to be fail fast. And how can we do it? Unit integration test, obviously, nothing really fancy. But now, you can consider using contract tests. Who has heard about contract tests? Good, quite a few people. So you can use Sprinkle Contract, you can use Pact. There are various frameworks that allow you to do contract testing. I am giving a talk that is an hour long about contract tests. Today, I'm going to give you that in 5 minutes. So hopefully, I have a lot of pictures, so that should help. So how does Sprinkle Contract work? A producer of an API or a producer of a message creates a contract, a Groovy file or a YAML file where it says how the API communication via messages would look like. And from the contract, on the producer side, we have a plugin, and that plugin generates tests to see if the producer is not lying. So if the producer says, I have such an endpoint, we will test it, because we, in general, trust the producers, but only after they pass the build. Otherwise, we want to break the build. So we have limited trust. And from the same contract, we generate stubs of the producer, HTTP stubs or messaging stubs. And now, the consumer can reuse those stubs as if the producer was there without running the producer. That's the very idea of contract tests. That's how the consumer can fail the build during build time if the integration is faulty. right? Because the consumer can start the stubs of the producer and see that, communication is malfunctioning. You can push all the stubs to Nexus Artifactory so they can be reused. So if a monolith does the contract and there are 100 consumers, every single consumer can just fetch the stubs from Nexus and simulate as if the monolith was running with you. So now what we're going to do is we will break the consumer. Breaking is fun. Let's do it. So we have a contract. It's a DSL. It's a messaging contract. So most important pieces are, we have some sort of a method that will trigger a message on the producer side, and here we have the message. So the producer says, what I can do is actually send a message to destination called messages with such a body. So this body contains fields username and repository. Okay, let's focus on that. The field, username, and field repository in the body. So from the contract, on the producer side, we're generating such a test. It hasn't been written by a human. It's generated from the contract. So on the producer side, we verify, hey, so if I execute this method that you said, will I receive the message from the topic messages? I will check if you have those headers that you said you will, and I want to see if you have the repository and username fields there, right? That makes sense? So we're verifying if the producer told the truth. Great. So the producer went to production, uploaded the stubs, and now the consumer creates a model that represents the POJO from the message, right? So we have username, repository. And now we're running a test, which means over here we use auto-configure stub runner. As you can imagine, stub runner runs stubs. So it's going to fetch the stubs from Nexus of the producer. Now we have a test, and initially we say, okay, we had no issues. Like the domain is issues. So when we receive the message from the producer, we're going to store it as an issue, like a domain concept inside this app. So initially we had 0. Now we trigger the stubbed message, right? So we simulate that the producer has sent the message to us, and now we should have 1 entry in the database, right? So we simulate it as if a producer was running and sent the message, to some RabbitMQ, whatever, Kafka, and we have taken it and stored in the database. So now, fun starts. Somebody breaks the compatibility. So instead of username and repository, we have user and repo. That's a breaking change. So the first thing that will happen is if the contract is changed, the build on the producer side will fail because the generated test wouldn't pass. So let us assume that somebody's insane and fixed it to make it, deliberately broke the compatibility, right? And uploaded the broken stubs to Nexus. Of course, that person most likely should be fired, but let's keep that aside to another talk. Things happened, right? So new stubs with backward incompatible changes were uploaded. So now when the consumer is built, it's going to fail at this step. Why? That's because when we're running again the same test, we're going to fetch the broken stubs, because each time we run the test, we're fetching the latest stubs of the producer. We're going to fetch the latest stubs. Initially, we had 0 issues. We triggered the fake message that now has the repo and user fields in it. And we're going to have a breaking build saying, we expected repository and username, but got repo and user. So without running the producer, every single consumer of a message or of an API can run the build locally and see if the current API calls or the way we process messages works fine. Does it make any sense? Kind of. Okay. So let's go to a more interesting topic, because you can say, okay, doesn't it mean that the producer, let's say, goes through the pipeline, all the consumers got broken, but the producer goes to production? That would be kind of true, which is terrible because everybody on production is going to be broken. So how can we stop the producer from this insanity? Let's break the producer. So let us assume that we have an HTTP endpoint, issues, that you can, let's say, trigger with the method delete, HTTP delete. So what we do is we create contracts that we describe this endpoint. We have that in the code. From the contracts, we generate tests. The contract, very simple, method delete, URL issues, status to 100, right? This test is generated. I'm going to send you the delete request, 2 issues, and I expect status to 100. Fabulous. It works fine. Great. So we've gone to production. Now, V2, we're removing the endpoint, because why not, right? So we are removing the endpoint. We have to remove the contract, because otherwise the generated tests would fail. And now, the problem is gone. There's no code, there are no contracts, no test. And if you don't trust me, this is the diff from Git that I really have done this. So we've removed the delete mapping, we removed the contract. Awesome. So now, what we would like to achieve, because now we are in the state that the new version doesn't have the endpoint, right? So if we had 2 versions running at the same time, V2 and V1, and somebody would send a request to the delete at issues, let's say we have round robin in terms of load balancing, every second request would fail with 404, right? Because there's no such endpoint. So in order to prevent that, what we want to achieve is, we want to see if the code of V2 is working against the contracts of V1, the version from production. So that means we're going to fetch the contracts of the version from production, we're going to generate tests and see if the current implementation is still valid. That way, we'll catch all the breaking changes, all the incompatibilities, and of course, that's going to break. So what's going to happen is that this step in the pipeline for the producer will fail. Over here, we've built V2 with the breaking change. Over here, we've managed to fetch the contracts of V1, generate tests from those contracts, and try to build V2. And it will fail because there is no such endpoint. You can run both of these steps even before pushing the code. You can run it on your local machine. Because this test will be generated from V1 and will be exercised against V2 of the app. Because there's the delete mapping is removed and there is no contract. Okay, so this was failing fast in terms of running integration tests, in terms of verifying on our boxes without even pushing the code if the contract is met. If 2 parties can communicate, if they understand each other via HTTP or messaging. Now let's go to the standardization and automation and the rolling back. So we have 4 steps. So we had build and upload, build the API compatibility check. Now we have test deploy, test smoke, and then test rollback deploy and test rollback smoke. If you standardize, you will lower support costs because you have to support only one way of doing stuff, right? You can also, in that way, enforce certain standards that your application, for example, has to be packaged in a very concrete way. Otherwise, let's say we don't accept it. That means that the learning curve for people, shifting projects, is going to be, much faster will you learn the new project, right? So how can we achieve it? There are various ways. I'm going to show you 2 that are quite simple. You can use a platform, and you can certain tooling. Tooling means it's a very generic thing. You're going to see what I mean exactly. Why could you consider using a platform? You can, let's say, write one, and I worked in a company where actually trying to build an in-house platform, and right now, knowing some platforms, I am more than certain that we haven't even thought of problems that were already fixed in a platform. So you have to consider what exactly you need, because maybe your in-house platform is good enough. Anyways, if you're using a platform, you can standardize the way you deploy and monitor your software, because the platform can, for example, accept only certain ways of packaging apps. Sprinkle pipelines, so the project that I'm talking right now about during this presentation that I'm mentioning only now, because what I'm showing you is very generic. You don't have to use any framework to achieve it. I'm just trying to first show you the deployment pipeline, what kind of steps I think are very valuable. And at the end of the day, I'm going to show you that all of that has been already implemented. So Sprinkle Pipelines is the project that implements the whole deployment pipeline. And it supports, out of the box, Cloud Foundry and Kubernetes as platforms. Who has heard of Cloud Foundry? Okay. Who has heard of Kubernetes? That was expected. And we support, out of the box, PCF Dev and Minikube, which are the let's say, versions that you can run on your laptop. Now, what else is given by the platform? It abstracts the way you govern your applications from the underlying infrastructure. So the idea is that regardless of whether you're running your app on your laptop, on Amazon, Google, Azure, whatever, you do stuff in the same way, or almost the same way as far as Kubernetes is concerned. So the concept is such, for example, with Cloud Foundry, that you have a CLI, you do CF push to push an app, and it doesn't matter if your PaaS is running on your laptop, on Amazon, Google, Azure. Doesn't really matter. Now, tooling. Who uses a tool to version the schema upgrades like Flyway, Liquibase? That's really good. Quite a few people. I'm very happy. So you can consider using tools to version the schema upgrades. So I am a firm believer that everything related to a given project, given app, should live with that code, live with that project, as far as it's possible. So database schema scripts, upgrade scripts, should also live with the app. And tools that allow you to do it are, for example, Flyway and Liquibase. I'm going to show you Flyway today. So let's focus on those two steps, test, deploy, and test smoke. The concepts we're trying to achieve right now is we've managed to unit and integration test the app and contract test the app. We have a binary that is built and kind of tested. So what we'd like to achieve right now is to test our app that got packaged, that we're going to deploy it somewhere, see if packaging is done correctly, and if in isolation the app works fine. We don't want to do end-to-end tests right now. That's why we call them smoke tests, because if our app has 100 features, 10 of them are critical, I would run smoke tests of those 10 features only, because we don't want to duplicate tests. We want this pipeline to be fast, and we want to check only the critical things over here. So how does it work? Here I have an example of Cloud Foundry, but you can replace the logo of Kubernetes. It works in the same way. Here we have a space in Cloud Foundry, which is, let's call it a server that is dedicated only for you, right? You don't see any other apps other than the ones that you govern. In Kubernetes, that would be a namespace, right? And let's say we have some services, RabbitMQ, MySQL, and Service Discovery, for example. So what we want to achieve is test the app in isolation against stubs. So I've shown you Stub Runner. The Stub Runner can also be a standalone app. So the deployment pipeline, what it does, it's deploying Stub Runner to this space, and Stub Runner knows, because it was told to, knows which stubs it should download or comes with those stubs. So if you're, right now we're deploying an app, GitHub Analytics. It has a dependency on GitHub Webhook. So one of those stubs would be GitHub Webhook. And what those stubs can do is Stub Runner can hook into the real Rabbit and to the real Service Discovery. So if you trigger a message, it's going to be a real message from a stub sent to a real broker. So we simulate as if a producer was running and sent a message to the broker, a real broker from which your app is pulling the messages. Over here, Stub Runner can store the stubs in Eureka or whatever else. So your app has no idea that it's talking to stubs. The first thing, what's happening when your app is deployed, it connects to the MySQL database, it upgrades the scripts, runs the Liquibase or Flyway scripts, and then it connects to, Rabbit and Eureka. So whenever, the message is received from the stub, GitHub Analytics doesn't know about this. It's just a message. Whenever it communicates with a service inside a discovery service, it's a stub, and GitHub Analytics doesn't even know about this. So we are capable of achieving tests in isolation of our app to see if packaging and crucial parts work fine. So another problem we're trying to solve is rolling back the database, right? So deployment pipelines, as we said at the very beginning, should test whether the application can be rolled back. Rolling back database changes is extremely difficult. So I remember that in one of the companies we're doing deployments in the night, and we're just praying for the database scripts in terms of upgrade, that they go fine. If that goes fine, the rest is okay. So, and we didn't have, of course, any rollback scripts, so that was kind of tricky. If you deploy every 6 months, that's even worse, right? Because you have so many changes that it's really unlikely that you'll be able to roll back. How can you roll back a deletion of a column? So that's kind of problematic. And coming back to that company I mentioned, at some point we said, okay, we are using Liquibase, and you can have rollback scripts there. So we enforced rollback scripts. The problem is that you can cheat it. So some developers started to put, like, select 1 = 1 in the script to make the script pass and to make the script be there. But if it got executed, that wouldn't actually roll back anything. And there are schema versioning tools that don't support rollbacks at all. For example, as far as I remember, at least, Flyway doesn't have this option. Okay, test rollback deploy, test rollback smoke. What happens here? So what we've managed to achieve is that we build the jar, we deploy the app to this particular environment, we executed smoke tests. And now what happens? We have a problem that we want to solve in terms of rolling back the database. If the problem was rolling back the database, maybe the solution, the Captain Obvious one, will be not to roll back the database. How about that? So what else can we do rather than rolling back the database? And why is it problematic? If we can ensure that we always do backward compatible changes, and we can actually enforce it, or we perform backward incompatible changes in a backward compatible way, a lot of backward in this sentence. You can read my post about this. It's called Zero Downtime Deployment with a Database, where I show that you can, for example, rename a column in 4 deployments in a backward compatible way. What if we leave the database as it is, but we roll back the app only, the jar? Okay? We can do it only if the application and database are compatible, if the changes are backward compatible. Why? Because we want to ensure that the old and new versions can simultaneously run against the same version of the database, so the latest one. So let's check out the demo. So we have GitHub Analytics. In the code, it's using Hibernate, whatever. And in the code, it's referencing a column called repository. And in the database, we have a schema v1 with column repository. Simple stuff. This is Flyway. We put it, since it's a Spring Boot app, we put it under source, main resources, DB migration. And we have 3 columns, ID, username, repository. We've gone through the whole pipeline. This is our schema, version 1, right? ID, repository, username. Now, we are insane. We're breaking the compatibility. We're renaming the field. We're renaming the column from repository to repo, right? So we are creating a very correctly named script, v2 breaking change, in which we say we even write a comment, this change is backward incompatible, and we alter the table to change the column from repository to repo. So this is the new schema, right? And now, if we go to production and we have 2 running instances, we're going to have a problem. Why? Because if you have v1 that in the code assumes there exists a column repository, and it tries to insert the data into the database where there is no such column, we're going to have a problem, apparently. There's going to be a disaster. So how does it work in the pipeline? Will we catch it? Over here, we verify that v2 of the jar works, let's say, upgrades the schema of the database to v2. And over here, we run some smoke tests to ensure that that's the case. Now, over here, we say, oh, I see that you've gone to production once. Okay, so the latest production version is v1. Great. So let me kill your v2 instance. I'm going to start the v1 instance, so the one that has gone to production, and I'm going to make it connect to the database with schema in version v2, right? So I'm checking, and I'm running the tests. So I'm running the tests against the version of the application running in production against the database change that comes from v2, so the current development one. And it's going to break. It's going to break because it doesn't know what column repository is. So this is how, in a very trivial way, we can catch breaking changes of the database. So that can save us bazillion, hundreds of thousands of dollars. Because if you don't have such tests, You have to, deploy to some environments, click around, see stuff. And this is tested in isolation. So let's say until now, we haven't called the other app, like the real app. We have only our app that we're testing, and we're testing in isolation. So those tests can be really fast, and they are checking a lot of stuff that, as you mentioned at the beginning, not a single person raised their hand in terms of rolling back. And now we have proved that we can roll back the app. Good. Now stage. So we have 2 steps, stage deploy and stage end-to-end. So, time for controversy, because I have a confession to make. I have a problem with end-to-end tests. And it's pure hypocrisy, because in the Spring Cloud team, I wrote the largest amount of end-to-end tests. But that's a different story. It makes sense over there. I have a problem with end-to-end tests that are written in a bad way, because typically there's so many of them that they take ages to run. They're also very frequently very brittle. Who loves debugging end-to-end tests? Okay. Oh, there is one guy over there. Good. So there's a problem, because you have a nil pointer somewhere, right? Or your algorithm is written in a bad way. And you run end-to-end tests and you get 500. Good luck, right? Now you have 25 services. Which one got broke? So it's problematic. And I've met some QA departments that told me, specifically, when I asked them, you have a UI test over here for a feature that gives us $10 per year. It takes 10 minutes to run it. So actually, we're not even earning enough money to pay for that run of the test. Why did you write it in the first place? So I heard, this is like a quote, seriously. So we write tests for every single feature because we're paid to do so. So I'm not really following this sort of, convention of writing tests. I think that end-to-end tests and UI tests and manual tests should be written for critical features. Now, there are questions, problems. How will you set up an environment for end-to-end tests? We have one environment shared between all applications, and now questions arise. We have 20 apps. We have one environment. 10 hours of running end-to-end tests per application. So already I have to wait 200 hours, or less actually, for my turn to run the tests. That's kind of scary. Also, who has ever had problems with data obfuscation because they couldn't put production data to stage? Oh, that's a couple of people. So, of course, we had, in one of the companies, we had exactly the same problem. I would never want to work on the team that, every day has to update the scripts or the code that obfuscates data. It's so, problematic because you cannot always generate data in the database. Often, the data has to have not only structural sense, but logical sense. For example, personal ID has to be very concrete for very concrete cases, right? So that's really problematic. Okay, so let's create one environment per application. Who's going to maintain that? Who's going to pay for that? That's tricky. Okay, another question. We often forget about this. Should we? So we have our app and 19 other apps out there, right, in our company. So if we have a developer's version that we're testing, should we surround our app? All the other apps, should they be in production versions, development versions, or both? That's a good question to ask. If both, I have to wait not 200 hours, 400 hours, because we have to run the test twice, right? And of course, it never happened to you with end-to-end tests. Often you have to, restart. Oh, now it passed. Great, right? So we were so, clever in one of the companies that we managed to split end-to-end tests into jobs in Jenkins, and you could execute just that particular test when it was failing. So instead of waiting for 10 hours, you would have waited 20 minutes because one particular test was failing. That's, of course, I'm trolling because that was a terrible thing to do. Captain Obvious solution. End-to-end tests are problematic. Maybe don't do them. Now, why? Because regardless of how much time you spend on QA, UATs, you will still have bugs on production. Why? Because production will test your production pretty well. Often we had UATs, everything went smoothly. On production, the app didn't even start because a file was missing or something else, right? You have different load balancer settings. This is problematic. Now, if you want to stop doing end-to-end tests, there are certain assumptions you have to take into consideration. The first one, the most important one, you have to embrace failure. I mean, really, you have to embrace failure. Not only you, your business has to embrace failure. That our apps, we're going to deploy them without end-to-end tests. We have some, suites of tests. We accept the fact that we will have bugs, but we can roll back very fast. That's the outcome. So this has to be a business decision. If your business is okay with that, if actually you calculate it makes sense to do it, you can consider doing that. If not, you should absolutely stay with end-to-end tests. Another thing you have to do in order to even consider not doing end-to-end tests is introduce monitoring of your KPIs, so key performance indicators. So you shouldn't just know that your app is healthy because it has 200s and stuff like that. The statuses are 200. You should know that from the business perspective it makes sense, right? So for example, if you are, selling cars and you go below 50 cars sold every hour, that means a disaster is happening, most likely. So you should monitor that. You should have, alerting over those metrics. So the moment you go below that point, you immediately get to know about this. Why? Because we want to know that at the moment we deploy a new version, we know that we didn't break stuff from the business perspective. Yeah, we have to know that we can ensure that we can roll back on production with a click of a button. So we get a notification from our alerting system, and we say, oh my God, okay, we have to roll back, right? So if we do that, we can consider stop doing end-to-end tests, but it's a consideration. It's not that I'm coming here and I'm trolling you. Immediately go back to work and stop doing end-to-end tests. It's a business decision that might make a lot of sense. But since it's controversial, those steps are still there. They are turned on by default. You can remove them. In Jenkins, you can just toggle them off. And there are manual steps, because you have to wait for your turn for the environment, and some manual work has to be done to purge stale data and do stuff like that. Okay, so we're almost at production. So we've done a lot of testing. Now production. Prod deploy, prod complete, prod rollback. What's the problem with deployment to production? Who loves doing deployment to production at night? Okay, there are some people. Good. So the ideal situation is that we don't do it at night, and we don't treat it like we open champagnes. Yay, after 58 months of development, we got a new version. No, we would like to even forget that there's a deployment. We get notified, oh, deployment, great. Why? Because if we do that, we have such a level of automation and notification that we can do zero downtime deployment, A/B testing. We can, for example, if we have a bug, we're going to have it only in, 5% of traffic, because we can route it, right, properly. But the crucial thing to even consider doing that is that we have to have backward compatibility maintained. Without this, we cannot have two instances running at the same time. If something goes wrong, we'd like to roll back. So the potential solution to this is a platform with sprinkler pipelines. So the assumption is also that we have the KPI monitoring in place, and we have those alerts. And since we've gone for the whole pipeline, we know that we can roll back. Now, why PaaS takes care of zero downtime deployment in a lot of ways, you're going to see in a second. In general, the idea is that platform takes care of load balancing and route registration for us. Now, in Sprinkler pipelines, we have the prod deploy task, which deploys the version from the pipeline next to the production version. Once we deployed, we tag the repo with prod/version. Why? Because that way, we know what's there on production, so we can run rollback tests against this, right? So we need to know which version got deployed. Prod complete, so you're running two instances at the same time. You have A/B, you see that everything is correct, you route the traffic. Okay, now at a certain point, you can just, let's say, complete the switch over, remove the old instance, or stop the old instance. But you can also do rollback, so stop the new instance, remove it completely, and remove the tag as if it was never running. So how would it look like on Cloud Foundry? So we have Cloud Foundry, those free services, Rabbit, MySQL, and Service Discovery. We have our GitHub Analytics app, this is the name, in version v1. We bind to those free services in production, and, Flyway is running, we upgraded the schema to version 1. What's happening, you can't maybe see it, we bind the route to this app, GitHub Analytics CF Apps.io. Great. So this is the management console in Cloud Foundry. You have a similar one in Kubernetes. So what we see is that we have one running app in version v1 bound to a GitHub Analytics route. Right? There's one app running. Now, we've gone to production with v1, time to go with production with v2. We renamed the app from GitHub Analytics to GitHub Analytics Venerable. I didn't invent this name, it's there. So we just do a rename. And now we deploy the new version under the GitHub Analytics name. We bind this instance to the same services. We upgrade the schema. And the crucial thing is, we route the traffic, we bind the route, the same route as here, to this app. So now the platform sees, under this route, I have two apps. I'm going to route the traffic between them. The platform gives you that out of the box. And then you have two apps running, the old instance, the new instance, and both bound to the same route. So this is the whole pipeline. Now, what is Spring Cloud Pipelines? So Spring Cloud Pipelines is an opinionated template of a deployment pipeline. It's a GitHub project. And it's based on, we didn't wake up in the morning and said, this is how you should do pipelines. So we got a lot of feedback from users, from customers. And we believe in the infrastructure as code approach. So we hate the idea of clicking jobs around. Who loves clicking jobs around in Jenkins? Okay, nobody, that's expected. So we believe that in case, automation server goes down, all the jobs are in the code. So I don't see this person here at the audience, but there was one guy with whom I worked, and I asked him to remove 4 jobs from Jenkins. So he wrote a script, a groovy script, but he mixed the equality with not equals. So all the jobs were deleted, but those 4. So fortunately, we had the seed job that regenerated all the jobs in no time, right? So this is the, mistakes happen. The setting up of Jenkins as such, or Concourse, should be automated. Concourse is automated by default, but Jenkins is not. So you should consider investing time in it, because most likely you have this beloved server with a name, with a beloved Jenkins instance that has been there since forever. You can't install any new plugins because you'd break everything. Actually, you can't even touch it because it sometimes breaks by itself. So we don't want this to happen. We want to, automate everything. Who wrote a test for their pipelines? One person, nice, or 2 people, great. So typically you don't even consider that, a pipeline can be a project that you can test. And we support following automation servers out of the box: Concourse, Jenkins using Jenkins Job DSL plugin, and Jenkins using Jenkins file. Now, logic of all steps is done with Bash. Why? Because you can convert the internals to suit your needs, regardless of the language framework used in your apps. You can use whatever automation server you want, because these are Bash scripts that require certain environment variables, and that's it. So you can use whatever is out there. And the pipeline knows whether you're using Maven or Gradle. You don't have to define it, the pipeline will figure it out. And since I'm a test freak, we wrote over 150 Bash tests. So if you're writing Bash and you're completely bored with this presentation, the thing you can take out of it is the BATS framework. So a framework to test Bash scripts. Really cool stuff. So how does it really work? So we have our Jenkins or our Concourse, whatever, and we have the repo with Spring Cloud Pipelines, the Git one. Over here we have a job. You can take it from us because we have it also in the code in the Git repo, or you can write it yourself. So that it will take the job definitions from the code and will generate the pipeline. Over here, we define in the repo with Spring Cloud Pipelines, we define the YAML for Concourse that has the definition of the pipeline. If you run this, you will generate the pipeline, right? And now whenever you execute a single step inside the pipeline, you run it with some environment variables that are required. So what happens is that a Bash script is executed, and this Bash script also comes from the repo. So every single time you run a step, this repo is either cloned or is already there, right? So this is how it works. So how do the scripts work? A little bit of bash magic. So this is the repository. There's a common folder, and there's all sorts of bash scripts. They represent a step in the pipeline. So we had a step called build and upload. If we go there, you see a simple bash script, not a fancy one. You have a build function. But where is the build function defined? Over here, we're doing sourcing. So right now, I don't know if I'm the first one in the world, I really doubt it, but I try to create an interface in bash. So this is an interface in bash because it has a function that exits with 1. So it just fails. So you have to override it in order not to fail your build. So this is the idea of an interface in bash. So we have defined how to build, right? So there is we have provided a declaration that there is a build function. And now, where is it defined? So, for example, in pipeline Maven. So if we see that you're using Maven, we have this function called build, and it really builds the project. We have exactly the same thing for Gradle, right? So if you had SBT, you would have exactly the same function build, but that does something else. And the same thing for pass. We support CF and Case out of the box, but if you had something else, like Ansible, because you don't have a platform, you would have a pipeline-Ansible. And for example, we have a function complete switchover, which essentially kills the old instance. So here is a definition. Here's a function of how we do it in Cloud Foundry. There's a similar thing in Kubernetes. So will my applications work out of the box? No, not really, because you have to follow certain conventions. We have different conventions for Cloud Foundry, Kubernetes, Maven, and Gradle. Let's just see a simple example of Maven. You have to use the wrapper. You have to parameterize settings XML. You deploy artifacts via the deploy task goal. There are certain properties that we inject to your build from the pipeline. Like, for example, latest production version is this. We run your build. When we do the API compatibility tests, we run it with profile API compatibility. For Smoke, with Smoke, and from end-to-end is E2E. So there is a bunch of conventions. What you do about this is up to you. But we have some, let's say, default understanding and samples of how we see it. Can you customize it? Yes, you can. It's a project, so you can download the zip, you can fork it, you can curl it, and you can run Gradle-W customize, because we have a CLI in which you can say, we want to use only concourse with CF, so please delete the rest. So whatever, if you choose to use Sprinkle pipelines, please, under issue 55, give me feedback on what you customized, because I'm going to put it in the CLI, right? Summary. Oh, we're going to have still some time for questions. We're doing continuous delivery and continuous deployment to continuously deliver business value because this gives us money. And Sprinkle Pipeline gives you out-of-the-box tooling to test your software via different sorts of tests, unit integration, contract, rollback. And the key thing to remember is that you can gradually migrate to start using this approach. You don't have to take all of it. You don't have to apply all the changes at once. You can actually check. Cora Iberclyde wrote a step-by-step. Actually, this is, for example, for Cloud Foundry, but for Kubernetes, that would be exactly the same thing, of how you can take an existing app that's a little bit, legacy app, and you can migrate it to use this approach. And you can adjust the pipeline by many ways because you have bash scripts, you have a lot of, say, Jenkins, for example, code, or YAMLs you can modify to suit your needs. And thanks to a platform, you don't have to, write any sort of in-house stuff, especially to do AB and zero downtime. Great. We have like 2 minutes or a minute for questions. I'm going to leave this slide with the links if you want to check them out. And time for questions. Maybe I have one question fast. Who understood anything of it, what I was saying? Good. So it wasn't that terrible. Time for questions. Any questions? There's a question. The question was, do we assume that we can have more than 2 versions of software running at the same time? The answer is no. We assume only 2, because if we had more, we have to already changing the approach of people that they have to write backward compatible changes is a lot. And with having 4 versions, imagine how much compatibility you would have to maintain. So 2 is enough, because you would have 4 apps in 4 versions, consecutive ones, working on, against the same database. So that's why we chose only 2. Any more questions? Any more questions? Okay, there's a question there. The question is how to upgrade the sprinkler pipelines thing. That's a very good question. So there's a number of ways. Let's say you fork the sprinkler pipelines project, and the best way, because it's still in milestones, so sometimes I'm doing my best to actually not not do any breaking changes, but sometimes I cannot. So what you can do is all the customizations you have, you can put them in a separate file. We describe it in the docs that you can, for example, if you want to customize the way you build and upload, under source main bash slash custom, you can create the build and upload SH file, and it's going to take precedence over the original one. So I would take this approach because that way you will not have conflicts when you merge the code from what we are doing. Does that answer your question? Good. Any more questions? Questions? I can't see any, I think. So, oh, there's a question there. How to deal with a project that starts up? So the question is, does it make sense to use this project in the case where you have a starting project that just starts up and is very volatile, right? That it changes a lot. That's a good question. I would start with this, and if it's just a project that starts, you can learn good practices. So if you want to change your API, do it in a backward compatible way. And if it's a starting project, it's pretty small, so we'll go to production in 15 minutes or like 20 minutes at most. So you'll be able to, let's say, break the compatibility in like 2 steps. Or if you know what you're doing, you can, temporarily toggle off certain steps in the pipeline, right? But my suggestion would be to, from the very beginning, do stuff properly, because you're going to, if you start with excuses from the very beginning, somebody's going to, use those arguments later on to toggle some stuff off. But that's a very good question. Any more questions? So if there are no questions, thank you very much. And if you have any questions, you can approach here and we can chat. Thank you.